So the question is about using the product rule to simplify radicals. So I know the book and Mobius stuff, it does things a little bit differently than I do because it tells you to find a perfect square and all this stuff. And oftentimes, I don't know, I just think it's a little bit more difficult to find a perfect square kind of right off the bat. So my method for doing it is essentially the same thing. I just go about it just slightly differently. So do you remember way back doing little factor trees? Like back in, I don't know, middle school or whatever. So I'm thinking about the numbers, that's 360, and I'm ignoring the variables for right now. And I just want to do one of those little factor trees. And I know that's, 36 times 10. The 36 I know is 6 times 6, and 2 times 5. And I'm just going to get down until I get to prime numbers, right? So 6 is 2 times 3, 2 times 3. And when I get a prime number, I always bring it down. I know a lot of people stop their factor tree when they hit a prime number, but I like to have one row, okay? Now, a square root, what you're looking for is a 2 of a kind, okay? Because a square root, you're asking yourself, what times itself is this number, right? So, I mean, there's a little bit of an aside. If I think about the square root of 4, what I'm asking is what times itself equals 4, right? So that's, if you factor that, that would be 2 times 2, correct? So the answer to that would be 2 because 2 times itself equals 4. So what I'm doing is I'm looking for pairs. And I see I have a pair of 2's here. So what that's going to do is that's going to kind of give me 1, 2 on the outside of the radical. Now, hey, that 2 disappeared. There. Now I also see a pair of 3's. So that's going to give me a 3 on the outside of the radical. And remember, when we pull things out, it's going to be a multiplication thing. Now I also notice that under here, we still have just a lonely 2 and a 5. And so that 2 times 5 stays underneath the radical because it doesn't have a pair to be able to pull it out. Okay? Now we have to deal with the variables. So notice I have a y cubed. So that's a y times a y times a y. Look, I have a pair of y's. So that's going to give me 1 on the outside. And I still have that 1 left that doesn't have a partner, so it stays on the inside of the radical. And then I also have those x's there, and there's 4 of those, right? So x times x times x times x. Here's a pair, so that gives me an x on the outside. Here's another pair. So that gives me another x on the outside of the radical. So now if I just try to simplify those, I get here 6 times y times x squared. That's all out in front of the radical. And on the inside, 2 times 5 gives me 10, and I have that y. So I find this a little bit easier to do than just spotting perfect squares, because I may not realize that the largest perfect square that divides into this is 36, which is kind of what the book is kind of asking you to do. So that's my method for simplifying the radicals when using the product rule. If you have any more questions or this didn't quite help, please let me know and I can clarify stuff.